An exponential equation is an equation where the variable is in the exponent. In other words, the variable that you're trying to solve for is in the air. If you were able to get a common base, then you can set the exponents equal and solve. If for some reason you can't get a common base, then you have to solve using logarithms, and that's another video topic. So let's take a look at this first example. I'm looking at these two numbers right here, and I need to take the 49 and the 343 and make those be same bases, numbers raised to powers. For example, 49 I know is 7 squared. And then I'm going to bring down that 3x plus 5. And then I'm going to say 343 is also 7 raised to some power. Now that may not be something you know just off the top of your mind, so what I would do is go to your calculator, start playing with numbers: 7 to the first power, 7 to the second power, 7 to the third power, 7 to the fourth power, 7 to the fifth power, and on until you find your number. It's actually 7 to the third power. And then bring down your 4x plus 3. Now that you have the same base, drop those bases and set your exponents equal to each other and solve. So if I solve that equation, I'll distribute that through and have 6x plus 10 is equal to 12x plus 9. Then you just solve. I'm going to subtract my 6x over. So 10 is equal to 12. Subtract 6 is 6x plus 9. Then I'll subtract my 9 over. So 10 subtract 9 is 1. Divide by 6, and x equals 1/6. All right, let's take the next one. So looking at this second example, seeing that 25 makes it pretty obvious to me that that base is going to be 5. And if you'd like to, try the problem on your own, pause the video and do that, and then you can come back and restart and check to see how you did. But I do know that that's going to be 5 to some power. So that's 5 squared. Bring down your 4x. Now this one is definitely one that you probably don't know. So again, go to your calculator and just start taking 5 to powers: 5 to the first, 5 to the second, 5 to the third, 5 to the fourth, 5 to the fifth. And you kind of have to get up there to some large numbers, but it's actually 5 to the 7th power. And then you'll bring down your 2x plus 6. Now that I have the same base, 5, things raised to powers of 5. Now I can set these exponents equal to each other and solve the equation. 2 times 4 is 8x equals, distribute your 7. 7 times 2 is 14x, and 6 times 7 is 42. Subtract your 14x over, so 8 minus 14 is negative 6x equals 42. Divide by negative 6, and x is equal to negative 7. All right, example 3. You'll notice in example 3 we have a fraction. Still do the same thing and try to get them to the same base. Now, you look at 81 and you might think, well, that's 9. Maybe that's 9 squared. But the deal is 27 can't be 9. 9 to the first, 9 to the second, 9 to the third. The numbers are too large and you didn't get 27. So let's go smaller and think 3. 3 to the fourth power is also 81. Here, 3 to the third power is 27, but notice where that 27 is. That 27 is in the denominator. What makes a number go from the numerator down into the denominator is a negative exponent. So if your number was in the numerator and went to the denominator, or technically it could be in the denominator and go back up to the numerator, you must have a negative exponent. That's how it gets down there. And then you're going to bring down your 2x minus 2. Now that you have the same base, drop those bases and simply set your exponents equal to each other. So this 4 will distribute through and give me 4x plus 16. Here that negative is going to come through, so that's negative 6x plus 6. Solving your equation, I'm going to add the 6x over here, and that gives me 10x plus 16 is equal to 6. Subtract your 16 over. 10x equals negative 10, and x is negative 1. Okay, your next example. Looking at this one, you can see that 10 can't be anything but 10. So that's going to stay 10 to the negative 5x plus 1. But then here we go again. That is in the denominator. So my base is 10. So I'm thinking of what numbers. Is it 10 to the first, 10 to the second, 10 to the third, 10 to the fourth? And it's 10 to the third. One trick is count those zeros. There's 3 of them. But because this is in the denominator, it's 10 to the negative third. You got to have that negative exponent if it's in the denominator. And then we're going to bring down that x plus 5. Now that we have the same base, drop those bases, set those exponents equal to each other, and simply solve your equation. Negative 5x plus 1. Distribute and watch that negative sign. He goes to everybody. Negative 3x minus 15. I'm going to choose to add the 5x over to see if maybe I could avoid some negatives. So 1 is equal to 2x minus 15. Add your 15 over. 16 is equal to 2x. Divide by 2. And x is equal to 8. Okay, let's take a look at number 5. Again, if you'd like to, pause this video, try it on your own, and then check to see how you do. So I'm looking at these. The base I need is 2. So I need 2 because 16 is 2 to the 4th power. That's 2 times 2 times 2 times 2. But again, that's in the denominator, so we know how it got there. A negative exponent, that's how it got there. And then bring down your 4x minus 1. And then over here, play with the calculator, play with those numbers till you can get. It's 2 to the 7th power. That's what equals 128. Okay, I'm going to drop those exponents, and I'm going to, I'm not going to drop the exponents. I'm going to drop the bases so I can set my exponents equal. And that's going to give me, distribute, negative 16x plus 4. Watch your signs. A negative times a negative is a positive. And then here, 7 times 2 is 14x plus 7. I'm going to add my 16x over. That's going to give me 4 is equal to 30x plus 7. Now I'm going to subtract that 7 over. So 4 minus 7 is negative 3. Watch your signs. Equals 30x. Divide. Be really careful here. We have to divide by 30. Sometimes your natural instinct may to say, oh, 3 goes into 30 10 times. But recall, to solve for x, you got to divide by the 30. So x is equal to negative 1/10 or negative 0.1 if you go as a decimal. Okay, let's look at number 6. Speaking of 6, we got to get a base, and 6 is that base. So let's think about 216. And again, you may need to kind of go over to that calculator until you find it. But it's 6 to the 3rd power equals 6 to the x squared minus 10. I have the same base, so drop those bases, set those exponents equal, and when I do, I will have 3x equals x squared minus 10. Remember, when you have a squared term like this, this is a quadratic, you're going to set it equal to 0 and factor. So I'm going to subtract my 3x over. So come over here. So 0 equals, now those aren't like terms. Let's don't put them together. Instead, write what you see, x squared minus 3x minus 10. And we want to factor this. When you factor a trinomial, remember that you have to multiply to get this, multiply to get this, but add to get that right there. Sometimes I'll call it a MAM problem. So what multiplies to get x squared is just x and x. What multiplies to get negative 10, but can add to get negative 3, is a 5 and a 2. Now look at your middleman. That's a negative middleman. So we need the negatives to win this battle. So negative 5 and positive 2 add to get negative 3, but negative 5 times positive 2 multiplies to get negative 10. So we're good. Set each one equal to 0 and then solve. X is negative 2 and x is positive 5. Okay, you're doing great. Let's look at number 7. All right, on number 7, we got to get the same base. So 2 is my base. So 4 is 2 squared. Now bring down your x squared. 32 is 2 to the 5th power. Bring down your x plus 5. We have the same base, so let's drop those and set our exponents equal. And when I do, I will have 2x squared equals 5x plus 25. Just as before, this is a squared term, quadratic, so we're going to set it equal to 0 and factor. If for some reason it doesn't factor, we'll use the quadratic formula, but I'm pretty sure this is going to factor. So subtract 5x, so come over here and subtract 5x. Subtract 25, and come over here and subtract your 25. That's going to be 0. Over here, none of those are like terms, so we can't force them together. Instead, we have to write what we see. 2x squared minus 5x minus 25. So we are going to factor this. And again, what multiplies to get this? What multiplies to get this? But my loops need to add to get negative 5. The only things that multiply to get 2x squared are 2x and x. 25, I could use 25 and 1 or 5 and 5, but let's try that 5 and 5 first. All right, let's check those loops. This inside loop, multiply and get 5x. This outside loop gets me 10x. And I can make a 5 and a 10 get to add to a negative 5 if I make the negatives win. So plus 5 and take away 10. That adds to get negative 5. So that loop is a plus. That bottom loop is a negative. And also positive times negative multiplies to get a negative 25. So we're good. All right, now let's take each one of those and set them equal to 0. So 2x plus 5 equals 0, and x minus 5 is equal to 0. I'm going to subtract my 5, divide by my 2, and get negative 5 halves. I'm going to add and get 5. All right, last one. This one's a little bit more advanced, but I like to try to show you all types of problems from the easier ones to the more difficult ones. Get a same base, get a common base, which is going to be 3. So that's going to stay 3 to the 5x. 81 is 3 to the 4th power. And 9 is 3 to the 2nd power. Okay, so I've got the same base, but here's the deal. This right here, that's a little bit different. I got to do something with that. You have the same base, and what are you going to do with the exponents? Well, let's think about what you would normally do. If you had, let's say, x to the 7th times x to the 3rd. If you had the same base, what would you do with those exponents? Well, your instinct would hopefully tell you to add those exponents. So we brought the base over and we added the exponents. That's exactly what you're going to do over here. You're going to bring that base over and you're going to add those exponents. So I'll say 5x plus 4 times 1 minus x, and then over here, it just is what it is. Okay, so again, I've got the same base, so let's drop those bases and set these exponents equal, and we'll be done. So 5x plus 4 minus 4x equals 2x minus 6. Collect your like terms. 5 minus 4 is x plus 4 equals 2x minus 6. If I'm going to solve this, I'm going to subtract that x over, and I'm going to add that 6 over and get x equals 10. If this video was helpful, please like and subscribe to my channel. This allows me to grow the channel so I can help build your math esteem one problem at a time. See you later.